want to talk about Scala for Java programmers and have a little agenda with us with important concepts. Scala unifies object orientation and functional programming. So we look into some of these concepts, like every value is an object. We look into mixed and base composition with traits.
Wait, Enno, is this really the best way to talk about Scala, you think? I mean, we want to learn Scala here, not define Scala, right?
Yeah, you're right there.
Okay, so we skip this one. What we really want you to learn.
The journey from Java to Scala is very easy. Scala gives us a lot of new possibilities, which we won't show you here. But they are there, believe us. And you don't really have to understand all these concepts we had on the first slide. They are there. You'll hit them sooner or later, but you don't have to understand them to start with Scala.
Yeah, so let's start with a warm-up then. Just to get it running. We divided this presentation into two parts, where the first part is really easy, where we just show how to get started to make things compile and work in Scala. The second part, it gets a little bit more tricky. We introduce a few new concepts and the pace will be higher. But don't worry about that, because after the first part, you already know how to program Scala. The rest is more like nice to have, see what the possibilities are. Some of the possibilities. Okay, so most of us, we are Java programmers here, right? So we have legacy Java code. So we invented some legacy Java code here, which is basically main method. We were thinking in lines of batch here. We have something that runs jobs for us. So we have some JDBC job factory. We can think that it probably gets jobs from the database. We pass it to job control and then stuff happens. What exactly happens is not that important. The important thing is to remember what this code looks like now. And we will get back to it by the end of the presentation. The first problem you will have when you want to convert from Java to Scala is to, how do you create your project layout? How do you organize your Scala and Java code? So here's something that we found work. First, you refactor your Java code. You take one module, one part of the code that you want to change to Scala. Start with one module only. And then you refactor that one so that it stands alone already in Java, and then put a Scala module in between. Once we've done that, then we can move code from the Java module to the Scala module and rename it Scala. And voila, we have now a Scala compilation unit, maybe is the word for it, that it doesn't compile because it's Java, right? But this is our first step in our conversion. So, this list here to the right to make it compile, you don't have to memorize it. What we did was we basically fixed one thing after another and noted down what we did. So we're going to do the same thing here. Go take one step at a time and see what happens and what the end result looks like. The first thing is that public is the default keyword in Scala. So that means that, or actually public, there is no public in Scala. If you don't specify public, then it will be public. So we remove the public. Variables in Scala, we have a keyword to declare them. It's var. So we have to add that there. And types in Scala are after the identifier. And I don't know if you want to say something about that.
The important thing is normally the name you want to define. If you have a variable, the name of the variable is the important stuff. If we have, as in Java, the type before, you normally don't find the name of the variable. And as we've seen later on, the types aren't, you don't really have to write the types in the code.
Yeah, pause that for look at this, how the types are scattered over the code. You have like types a little bit everywhere. And now let's do the change in Scala. I noticed that on the flight here, actually, how it aligns neatly. The types are on the right side and the names are on the left side. So I think that's kind of nice. Then generics, they choose another sign for that. It's square brackets. So let's just change that. What?
We're done there?
Yeah, we're done with that. And we declare our functions with def. They're called functions in Scala, not methods. So then that's done. And def, it stands for define something. So then the definition should come after the name, I guess. So then we put an equal sign in between there because we sort of define this name to mean whatever is after the equal sign. So we insert that. Then comes a little bit of an odd thing in Scala for Java, for a Java programmer, that the void keyword here. In Scala, the equivalence of the rough equivalence is unit. So you can use it interchangeably, and in fact, Java methods will be converted to unit when you call them from Scala. But unit is a value; it just doesn't have anything on it. So it's not that important. You can think of it as a void, but it is actually a value, and there's a single instance of it. So, when we did that, the last thing we need to do is we need to initialize our variables. Scala requires that. So, we do that. Yeah, and now we have actually something that compiles. So, we're done. We're Scala programmers. Simple, right? But of course, if Scala was only about this, then it wouldn't be much of that big a deal. So we can also remove some redundancy here.
And the redundancy is, some Scala tricks. The last statement in a block is the value returned. So we don't have to write return. We just remove it everywhere, and the last thing is the one we return. The types are inferred. So the Scala compiler looks into what we write and understands the type that is returned from the other types that are around. So we can just on these places remove the types. If we don't write this equal sign for the methods, the Scala compiler understands, okay, that there's nothing to return from that method, so unit is understood implicitly as well. And if we have blocks with just one statement in it, we don't really have a block. It's like if sentences. In Java, it's often good practice to write the parentheses there as well, but you can do without, so we can remove it here as well. And then there's this useful thing, useless thing of a semicolon on the end of the line. We can just skip it. It's allowed to write it there, but yeah, we can get around without. So now we have a bit more Scala thing. And the same code can be expressed even shorter in Scala. And the important thing here is it is still an equivalent to the Java code we had at the beginning. We used some notations here that tell the Scala compiler that we want to have the Java view of these fields. So we get methods and set methods for all the fields we have declared in the class. So these two things are exactly the same from the client point of view.
Yeah, so if you're using some web framework, for instance, name one that uses getters and setters extensively, then it's quite easy to write these data structures here. Now, a Java program, I guess you all see that this is not an immutable structure. You have like getters and setters, and that's bad practice, right? We always write final on our, right? Yeah, Scala allows Scala allows us to write small code. That's what we want to say, and it's more compact. It's still Java. So the first thing we want to do is we want to make it immutable, don't we?
And Scala distinguishes variables and values. So we have the var keyword, which tells us this is a variable, but we can just change it to values. But the first thing we want to do is to add a constructor to this class. So the only thing we have to do there is to change a little bit. And now you see that the fields from the class became parameters to the constructor. The constructor is defined on the class. And now we get back to the variable value thing.
Just to mention one thing here, that's like, can you see what we don't have to write here? In a Java class, if you would have a constructor here, you would have like a constructor, right? That you would have to declare the fields in the class that they are there, and you would have to also assign them in the constructor. But in Scala, we say that when they are in the constructor, they are also accessible as fields in the class, which is pretty often exactly what you want, right?
So now we get back to what I mentioned before. The variable keyword is changed to the value keyword with val, and now they are read-only. So it's final fields in Java world.
Yeah. And Scala actually removes all the setters by that change there also.
Now we want to use default arguments, basically default values for these arguments in the constructor. And that basically means if we don't name the field when we call the constructor, it will fall back to this default value. So what we introduce here are the default values that are assigned if we don't use it. So we have a little example here where we just use the same constructor, which normally requires all these three fields, but we just use the name field. So the compiler understands, okay, we just set the name field, so the other ones will be the default values.
And the thing is that you can, if you want to, you can specify fields by position, like in Java, like you would do. And this is actually quite new in Scala, like by name references. But what I think is interesting with by name here is that I think it totally eliminates the goodness of setters, doesn't it? One thing that is really good with setters is that you can actually read what you are setting, and you can leave some things out if you don't want to set them. You can have sensible defaults in your constructors, but now you can actually, in Scala, you can express all that, but still have an immutable object with the constructor.
We can have a short question here. Has anybody written a class with about 10 constructors in Java? When you have lots of fields in the class, you get more and more combinations of the constructor fields, and just call this. And this is definitely eliminated because we can get around with just one constructor.
No one wrote 10 here, 5? Okay. Yeah. So it happens because of these combinations. So now we have an immutable class, so immutable bean, setters only. This step here, you may not want to do it right away. We showed it here because it's easy, but you may have a lot of Java code that actually depends on all of these setters and the mutability of the object. So depending on what your Java code looked like before this, you may want to wait with making it immutable, but this is how you do it. Okay.
So why Scala? Why? I mean, did this really give us anything? Would anybody think so? The question that is more important to us is why not Java? Because Java, I mean, I've been coding Java a few years back in time, and it has had this journey, and the language has evolved. We had inner classes somewhere in 97. Then we had some new keywords here and there. We had the generics leap. That's really where the language evolved quite a lot, a huge change. But at the same time, if we look at what generics gave us, there are rough corners. It is very, very hard to introduce new concepts to an existing programming language without breaking backwards compatibility. And this is shown with the generics. There has been much criticism around the generics, and it is because it is very hard to get good concepts into an existing language.
How many in here are programming in Java? Yeah. How many are using generics? Oh, good. And so that's like half.
And now we looked into Java 7. Many of you will have been following what's happening there, the new language changes. And everybody expected huge changes, but in the end we come with a little product coin, which gives us a few new operators in the language, because it is so hard to introduce these new concepts into the Java language without destroying old stuff.
I think we had a question here. No? Okay.
So we ask us, is Java dead? Have we seen everything with Java? And no, it's not. Of course not. I mean, COBOL is still around.
Maybe Java is the new COBOL. That's what we're going to solve the new year 2000 and something problem that will arise, or I don't know.
2010?
Yeah.
But Java, is Java dead? No, nobody would say that. Java is more than the Java language. Java is the whole Java platform. We have the Java virtual machine, which will be there much longer than anybody of us. So the JVM is still the future, and what we are looking for is some new ways to use the JVM efficiently.
So, why Scala again then? I think one thing that was really appealing to me after I saw Enno's first presentation at my company about Scala, one thing that really appealed to me was that it's bytecode compatible with Java. What you get out of the Scala compiler is actually Java, so it interacts with your existing Java programs, and you can write Scala programs that Java programs can use. And I think that's an important feature. Why? Because I think Scala is probably something that's most considerable if you already have a lot of Java code. If you're starting from scratch, then you probably have a bigger choice. But I think bytecode compatibility is really an important part of Scala. It's designed for extendability.
And that's back to what we saw with Java. Java is kind of stuck in how the language looks today. It's so hard to evolve it. Scala takes another way there where it is not always obvious when you look at Scala code if you're talking about the language Scala or the API you're using just in this bit of code. And that makes it extendable. You can introduce new things that appear as keywords or structures in the language, but basically are solved through API. And that makes it much easier to take stuff away and to add other stuff later on as we see that, okay, that was the wrong way. We just use another API and get better at it.
Yeah. And also what we will see a little bit in our further on in the presentation also, we will scratch on the surface of a higher level of abstraction, and functional programming is a big component in that. So I think that one thing that's so appealing that I'm still discovering new things every day that I look with when I work with Scala is like, wow, that's a neat thing. I didn't think of it. You could do it like that, and then I can express the same thing here. I can say what I mean, not what exactly how to do it. I can program in a more declarative way, which I think is a huge benefit of modern languages, which is what actually takes Scala a step further than Java, where Java is quite verbose to say pretty much anything. So, the thing is that as much as I hate to have a quote by Henry Ford here, so many bad ideas came into software development from Taylorism and so. But one thing that he did get right, I think, is this quote, many other as well, is if I'd asked my customers what they wanted, they'd have said a faster horse. And I felt a bit like that. You know, I didn't quite appreciate all the new things in Scala that I had never used before. And it took a while of using them and failing with them and succeeding with them to actually appreciate that they're there, to the point where I sit every day and like, God, I wish I had a fold left now. That would be neat.
And what we want to say here is, you don't know that you want it.
Trust us. We're not selling this, by the way. Okay. So that was the first part of the presentation. Now, how many here are familiar with the functional programming, have tried it a bit? Still quite a few. So lots of people will be able to follow. Others will maybe, hopefully, see what we're trying to do with it, but maybe not get the details. It's not important. You can already program in Scala. The first part is what you need sort of to get started.
So if we lose you here, not a problem. We just want to show possibilities. Get ready.
Yeah. Okay, back to our project layout. We take something more real and put it in Scala, some class that actually does something, not just a data structure. Bean. So,
And here we have the Java code for it, and we just quick and easy make it to compile and make it be Scala code.
you remember all the steps, so it ends up something like this, right? The new thing here that you haven't seen before is this for loop syntax.
And this one doesn't compile now, because here the job get steps will return a Java type which doesn't have a for each method, which is required for this for loop. And this is called structural typing, and we won't get deeper than this. But we can get help here.
Yeah.
We can import Java conversions, which will help us to automatically convert this Java type to an appropriate Scala type if we need it. We can think about it as auto-boxing, as we have it in Java between basic types and object types.
And this is actually one of the ways in which Scala is extendable, that you can actually define your own auto-boxing that makes sense in your domain. Maybe it makes sense for you to convert strings to some domain-specific object that the generic language designer could never have thought about, but it makes sense in your domain. Then you can actually make those rules and import them into your program. That's just one of the ways where Scala is extensible.
And now we want to highlight a little bit of code here. Do you like this? We don't either.
No.
Scala hates null. We want to remove null from the language, but we can't because it's there.
It's deep down there in Java. It has to be there. So we have to deal with it in Scala. Scala allows null. And that's actually one of the most painful things about
it. Hates null.
It allows it.
It allows, okay.
Yeah.
Sorry.
So, Scala loves options instead. That's one way to deal with null.
Without null.
Yeah, exactly. So to accomplish what you want to accomplish with null without some of the side effects, that's one of the ways. And options is something we want to talk about here because that's something you will run into pretty fast when you start learning Scala. So we go to our job factory and we magically introduce a new thing here. Anybody heard about traits?
Trait is kind of an interface in Scala. The difference to Java interfaces is that we can add code here as well. But we want to introduce a new method. Create is the method that was required by the Java code. What we want to introduce is a method apply, which then returns this option construct, which we talked about just before. And there's something special with this apply name, but we'll see it later on. We can, as we have a trait here, implement this method we require. So we add some implementation to the apply method, which will use the create method and put the null check in here, and then return an option. So yeah, there's still null around, but because we create was something Java defined, Java method defined, but we now package, depending on if we get null or not, package it into an option. An option as a return type indicates to the Scala programmer, okay, here I get something or I get nothing. So it gets indicated in the API that you have to deal with the case that you don't get an object.
Yeah. So remember these. None means nothing, empty. Some means something. And it's like 0 or 1. There's not 0 to man. There's 0 or 1. And also, one important thing about Scala, it's with its functional inheritance here, it's like everything returns. What? Everything here returns a value. So this if statement, it is on the last line, and you remember we don't need return because the last statement is return the result of that. And here the last statement is an if statement here, if else. So the return would either be this or this. And that takes some getting used to, but it's actually quite neat. And yeah, an interesting thing there also, like in Java, there's no way really to, just return something from an if statement to the calling method. You would have to define a new method to be able to do that, or the return statement will exit the whole method. So that's a subtle difference that sometimes you can get away with less of extracting small methods.
But this interface job factory, we want to use it from Java. So we have to combine this trait job factory with a bit of Java plumbing code.
Yeah, because these traits, that's we didn't say this out loud, but this is this code here. You could see it as compiler copy paste. When we use this trait, the compiler will tuck this code here into the class where we use the trait from, and it's called mixins. And some people maybe tried Ruby or something and are familiar with the concept.
So for the Java, we add some plumbing, and that's not more than this. We create an abstract class which extends objects, basically nothing, with this job factory stuff.
Yeah, we have to do this because Java doesn't have this automated cut and paste compiler thing. So we have to sort of give Java some abstract class, the class that contains this code. Okay. So we can also do something about this if-else. A more Scala way to do this, it would be to do something that's called pattern matching. And this is not the same as a switch case in Java, and there is a lot to pattern matching. We could probably talk a day about just that. But you can see this is essentially the same as this if-else, and if we would remove this space in between that we kept not to move things around too much, then it would be more compact way of writing it.
What Scala helps us with is to make sure that we take care of all the cases we could need here, which if sentences, if clauses doesn't really help us with that.
Yeah, let's say that we had like more than 2 values, then Scala would nicely indicate a warning there that you are not taking care of all the cases here. Good. So
now we want to make use of the job factory apply method in our Scala code. So here we still use the Java version with JF create, and we now want to change to the improved stuff, which is the apply method. The apply method returns an option, and the option has either a value or it doesn't. So we want to get the value, or if it doesn't have a value, we want to use this empty job constant. This way we make sure the job always contains something meaningful in this context.
And that's it takes a while to know, like, okay, what's the big deal? I mean, like if else, like if null, like what's the difference? And the thing is here that the option, it guarantees that there's no way you can get a job from the option unless you say what you want to do if there is no job. Null, you have to know that it can sometimes be null and you have to deal with it. So it's much more explicit this way. And you're not allowed to get the value unless you provide an alternative if there is no value. Everybody with us? Right?
And in this case, we just put in a constant value, this empty job constant here. But that, okay,
Yeah.
it's not yet.
Not yet. We told you about the apply method here. The special thing about this is that if we don't specify apply, just call like on the object, then Scala interprets that we are calling apply actually.
So it's some kind of default method and applies the name of the default method. And you can have different parameter lists for that, so you can have many apply methods. But kind of a shortcut.
Yeah, it's still our same old factory here. We can put code in here. Here we put a side effect. If there is no value, we'll print hello on the console, and then we will throw an exception instead. And then we're entering the domain of functions. This is actually what this thing up here is actually an anonymous function that we declare here in place, or a closure if you wish. And so let's talk a bit more about functions. When I started, learning more about functions to refresh my memory, it helped me to think of them as something that takes something and turns it into something else. So my metaphor for that is a transformer. You take altering current on the left side and you get direct current on the right side of some value. So Scala basically has a notation for that. It looks like that. It basically means this is a function that takes an instance of AC and turns it into an instance of DC. Is that clear? Yeah. And now we have a value here, transformer, that is of the type function, and this is the thing here. Like functions are values like anything else, and types to the left of the to the right of the colon, and the value to the left. We can, of course, have other functions. So if you think of our factory that we had there, basically we take a string and then we turn it to a job if it exists, an optional job. So our factory that we had in the slide before here, that's actually, we could see it as a function that turns strings into job options, right?
And for this type, we could have a more Java-like notation, which is with generics. And this exists in parallel in Scala as well. These two things mean exactly the same thing. Whereas the first one is more like, it comes more natural after a while, whereas the other one is more how we could write the same thing in Java as well, if we really, really wanted to.
And the second notation here, it makes it really clear that functions are just objects, right? So if functions are just objects, then we should be able to extend them, shouldn't we?
So here you can think of this type function as an interface with two generic types, one for the input parameters and one for the things that come out. Back to the code.
Yeah. We can move into our factory. So let's go to our factory here and let's make our factory into a function. And as we said, we hinted that we should be able to extend them, so let's do that.
So what we say here is the trade job factory is extending this interface, or whatever we call it, function with this parameter list that we saw before. So the whole class is stated to implement a function, which could be written in this other notation as well. Here we use the job factory as a type in here. Oh, you have it marked there. But it doesn't really do much more than this method that takes a string and returns an option of job, which we want to put here. So this job factory fulfills the type string to option of job.
So the thing is here, like from having a specific factory here now, we can take anything that turns a string into a job option. We can pass that in. So now we don't have to extend that factory there if we don't really want to, but we may still do so. So this is a more abstract dependency here. We have decoupled ourselves a little bit from our concrete factory here. And that allows us to write factories really easy because, functions in Scala, they are so easy to define. You just define a method there. This empty job factory definition up there takes parameter name of type string, returns some new job, passes name in there, and empty list, empty Java map.
So if we had written a type on this method, remember, we don't have to write the types, but we could write the type as well. And that's exactly the same type we used on the slide before, string to option of job.
So we can just pass it down there to our job control as our new job factory, which is defined with very little boilerplate there, just the essentials.
And in the more Java way, we had to have this extend the class of job factory, implement the method there, and then send this class in. We get rid of it.
We're back in our main here.
So if we look at it now, after all the stuff you've seen before, we have still the main method in Java, but many parts of it are defined in Scala.
See, it didn't change, did it? It's exactly the same now from the outside. So from a Java perspective, we still have the same Java classes and everything, but behind the scenes, we can actually use functional programming in Scala without even noticing from the outside. And this is how neatly Scala and Java blends if you do it correctly. It's not that straightforward. I struggled a lot with. I made a lot of different mistakes that were not as straightforward as this to be able to mix and match. But after a while, once you get the hang of it, you can actually really move very effortlessly between functional and object-oriented programming in Scala, which does open up a whole new dimension of possibilities that I didn't even know that I wanted before. Okay, to sum it up here. You don't have to do everything in Scala right away. You can stop right before our Millennium Falcon there picture. You can stop right before there and just code Scala like you would like you would code Java, and that's okay. You would get a little bit nicer syntax, some type inference, and have to type a little bit less. You wouldn't get all the benefits, but maybe it would be enough to make it interesting.
And after a while, you'll want to tap into all the new things that Scala gives you.
But you can do so at your own pace. And I saw a lot. I've been reading a lot of forums on the internet, and that's actually Scala got a little criticism for that. Like here you have this really advanced thing with lots of things that you don't really get. It's really hard, and then you just say, you don't have to use it all. You can use the same old Java stuff. Then what's the point? But the thing is that when you start using it for a while, it looks like it's a lot in Scala, but it's actually in some ways simpler than Java because it's very consistent. There's a very small set of rules that you become more and more familiar with and start to expect from things. So it looks like really huge and mind-boggling Scala, but it actually is quite well thought through. It's very neatly implemented.
So it's very easy to get going as a Java programmer to use Scala. But once you're there, you're trapped. You don't want to move back to Java. You really miss the things when you go back to Java and all the stuff that's in there.
And what I notice for myself also, when I code in Java now, I find that I use some patterns that I picked up from Scala that are actually possible to do in Java in some way. Some things are a bit more cumbersome, so you won't be that functional in Java. You can do it, you can use anonymous classes and so on, but that will be so much boilerplate around it so you don't see what's happening. It's not making things clearer. But some of the patterns there that you learn in Scala, you can bring them back, and there are actually some places where you can, for instance with anonymous classes, exploit the same things in Java. Not maybe as nice, but nice enough. It will add some value.
In the end of the day, all the Scala code is compiled to the JVM. And the JVM doesn't do much more than Java allows us to do. So it's everything you can do in Scala is possible to do in Java as well. But you will have years of writing Java code where you miss the meaning of why you did it just because to get it right.
Yeah, it doesn't make sense. Like if it's as easy to write a function in Scala as like put two curly braces there and some code in between that, then you would probably use it. Then if you have to do like new some class, I have to make up a command, curly brace, the method, and once you remove that boilerplate, it becomes actually accessible. It's still there, but it's accessible that way.
That's all we want to say for today.
So now you can ask questions about performance and things that you're wondering about. Yeah? No? Yeah. What about performance? Yeah. Well, in the end, it is actually just Java bytecode that gets executed. The thing is that what is hidden behind the Scala text is not always obvious as it is in Java. In Java, it very much sees what you get, while Scala is what you see is what you mean. So there may be more anonymous classes and so on that are created that in some instances may have performance impact. But in general, sometimes Scala is faster, sometimes it's slower. But on average, I think it's very comparable.
One thing Scala gives you much more than Java is the thing with the immutability, because that will make the garbage collection much more effective, as the garbage collector can see, okay, this object will never change, so it can work with it in another way. And even more interesting is the immutability that is more natural in Scala when we talk about concurrent programming. Has anybody done concurrent programming right?
I think the thing is with it's not like you can't write immutable code in Java. It's just much harder because you don't have all the other tools to work with it effectively. I think so. That's I guess the message. To be able to do that, you need more tools. More questions?
Have you found some kind of applications which are more suited for Scala and some which currently aren't?
You mean more suited for Scala than in Java and?
I think if you like interfacing up with some kind of libraries that you found it hard to do that.
There may be some. I mean, some libraries are, Java libraries. They are very much mutable code. It's not like you can't use it from Scala. Like for instance, Spring, you have a lot of setters on everything, and you may still use that. I mean, Scala does not put any obstacles in the way for doing that. So what is really popular at the moment, I see that lots and lots of wrappers are around popular libraries. So you can have, a really neat Scala layer on top of some popular Java library like OSGI or some Spring stuff or
Swing as well.
Yeah.
Because in Swing you have all the event listeners and that stuff. That just becomes closures in Scala. So it becomes a much nicer interface with the possibilities Scala gives us.
Yeah, that's a good example where Scala actually adds value to something we already have here. Yeah.
What about comparing to all these others, Ruby, not a lot of
Okay. The question is about how it compares to other languages on the JVM. And there are many other interesting languages around on the JVM. That's for sure. What Scala does more is like the statically typed. There is a type system behind Scala, which the dynamic languages, that's why they are dynamic. They don't have it, and this gives another level of security while we are coding, because the compiler will track down some problems we have, which we won't necessarily see before we run the program in dynamic languages.
I think there's a backside to that. I mean, the thing is that Scala is more similar to Java in that sense. It is statically typed. So I think in that way it's more easy to introduce Scala to Java programmers because, you used to have some people like cling to the type systems and some don't. There are things that are possible to do in dynamic languages that you can't do in Scala because it's static. Like there are some kinds of dynamic meta-programming and so on that is not possible. You can come pretty close in Scala with the structural typing and those kind of things, but you're not really there, same as in Ruby or Python or other dynamic languages. But it is a statically typed language, so similar to Java in that way. Yeah.
What about IDE support with
The question about IDE support, and no, it's not good. It's coming, and it's much easier for Scala to provide good IDE support than for dynamic languages, because there is a type behind it. You know what methods can be called on this object. So there are plugins to Eclipse and NetBeans and IntelliJ. It's not good yet.
No, I struggle a lot with Eclipse, and actually the nightly build of Scala 2.8 for Eclipse is more stable than the earlier version because they changed the architecture completely around Eclipse 3.5, but it's not available for Scala 2.7. And Scala 2.8 should be done about now. But IDE support is pretty crappy by Java standards compared to what you're used to. I've been using Eclipse, and you after using it for a while, when you're patient, you find your ways around problems and so on, so you can sort of work with it, but it requires some patience and figuring things out. I talked to Jonas Bonner here before, and he said that he's quite happy. I guess all is relative with the IDEA plugin, so that's apparently shaping up now also. So it's getting better and better. I mean, for the time I've been using Scala, like the last year or so, then I have already seen improvements, but there's still, compared to what you used in Java, it's not even close.
But you need much less functionality in the IDE plugin, because what the IDEs give us today is creating getters and setters and all this kind of writing code for us. It's not that important in Scala because we often don't have to write that code.
Yeah, the compiler takes over a lot of the job of the IDE actually, so that's the good thing. But still, you want your code completion to be able to explore the libraries via, and that it's working-ish sort of. It's okay, but sometimes it crashes. My advice to everyone trying Eclipse, like, make sure that you set up the amount of memory Eclipse has. Okay, 3 more minutes. If there's not any more questions, I think that.
Thank you very much.
Thank you very much.